Welcome to Spring LIB.
So in this question, we have a wave in a row that's traveling with the speed of 8 meters per second. The amplitude is 0.07 meters and the wavelength is 0.32 meters. In part A, we're looking for the frequency, the period, and the wave number. Now let's start by finding the wave number. The wave number k is equal to 2 pi divided by lambda, which is equal to 2 pi divided by 0.032 meters, which is equal to 19.6 rad per meter. So this is the wave number, k. To find the frequency, we're going to use the formula of the speed of the wave, v equal lambda times frequency, and from this we can write frequency is equal to v divided by lambda, which is equal to 8 meters per second divided by 0.32 meters, and that's equal to 25 hertz. So this is the frequency. To find the period, t, it's equal to the inverse of the frequency. So 1 over frequency, which is 1 over 25 hertz, and that's equal to 0.04 seconds. So this is the period for this wave. Now, for part B, we have to write the wave function for this wave. Now, the general form of the wave function is y of x and t is equal to a, the amplitude, cosine 2 pi. So here I will put 2 pi multiplied by x divided by lambda plus t divided by the period. Now, we have everything we need here, so we can write the wave function. Notice here, I put a positive sign here. I had a positive sign because the wave is traveling to the negative x direction. That's why I have a positive sign, because the wave is traveling to the negative x direction. Now, y of x and t is equal to the amplitude, which is 0.07 meters, multiplied by cosine 2 pi x divided by 0.32, which is the wavelength, 32 meters, plus t divided by 0.04 seconds, which is the period. So this is the wave function for this wave. Okay. The next part, we want to find the transverse displacement. So part C, we need to find the transverse displacement for x equal to 0.0 or 0.36 meters, and for time equal to 0.15 seconds. Now we're going to use the wave function from here. We're going just to plug in x here. We'll just plug it in, and we'll plug in t. And then we just need to use a calculator to find the answer. So y of 0.36 and 0.15 is equal to 0.07 meters multiplied by cosine 2 pi. X is 0.36 meters divided by 0.32 meters plus time, which is 0.15 seconds divided by the period, 0.04 seconds. Now notice here, the first thing, the argument of the cosine will be dimensionless because all the units will cancel with each other. So now we can continue our solution and we can write 0.07 meters cosine 39 pi divided by 4, and that's equal to 4.95 times 10 to the power minus 2 meters. So this is the transverse displacement of the rope at that time, or at these coordinates. Okay, the last part is to find when the wave function will have a transverse distance, or a maximum transverse distance before that time, or before that position. So yx and t will be equal to a, and this will happen only when cosine 2 pi x divided by lambda plus t divided by the period will equal to 0, it will equal to 1, and that will be only if 2 pi x over lambda plus t over period is equal to n 2 pi, where n is an integer, so 0, 1, 2, etc. Okay, and from this we can see that the condition will become x over lambda plus t divided by period is equal to n, and if we solve it for t, it will become t equal the period multiplied by n minus x over lambda, and from this we can see that t equal the period 0.04 seconds multiplied by n minus 0.36 meter divided by 0.32 meters. And for n equal 4, the time t will be equal to 0.015 or 0.115 seconds before the instant of part C. So before the instant of part C. So this is the answer.